Hi there, I want to talk today about two things: corrosion of metals and alloying of metals. Corrosion of metals is caused by the chemical reaction of the metal with oxygen and or water. Let's look at a typical example. Iron reacts with oxygen and water. In fact, it reacts to form rust. It turns brown. Chemically, this is what happens. The iron Fe reacts with oxygen to form iron oxide, and then that FeO reacts with more oxygen to form Fe2O3. Add them together and you get Fe3O4. Plus there's water involved. I'm going to put an X, H2O. So that is what rusting's about: oxygen and water vapor or steam makes iron corrode. Another example of corrosion is if you took aluminium, it reacts with oxygen and it turns whitish because you've got aluminium oxide formed, and then if you scraped off that it would react with more oxygen, so eventually you get less and less of the aluminium present because it's oxidized. You get iron again. It tarnishes, I'll come back to it, and you can nickel plate, chromium plate it to stop the metal from corroding. Methods of stopping corrosion: anti-corrosion, so things don't corrode. The three metals are greasing, painting, or another method's called sacrificial protection. I'll look at these. Sacrificial, I can't spell, protection. The first two there, it stops moisture, oxygen getting to the metal, and often these may contain an anti-corrosion agent. Particularly in the paints, they may contain zinc, but in the next example, when I talk about sacrificial protection, we'll see what that's about. As we're there, let's look at sacrificial protection. Imagine I've got iron and it's coated with a layer of zinc, and there's the iron. Zinc is more reactive than iron, so if you cover it with a layer, galvanization by the way that's called, what happens is the zinc reacts with oxygen to form zinc oxide before it reacts with the iron. So that is what is meant by sacrificial protection. Here's a boat, a ship, and the ship is in salt water, sodium chloride, and there's also oxygen in the water, and there's the water. What happens is the steel hull of the ship or boat starts to corrode, so what they do is they put blocks on the bottom of the boat made of magnesium. There's the magnesium block, so rather than the steel being attacked by those elements causing it to rust, they use magnesium, which sacrificially, if you say, rusts, corrodes in preference to the steel hull. Alloying next, I've mentioned this in a previous video clip, is mixing a mixture of metals to change the properties of the metal by itself. For example, gold is soft, copper is quite soft, iron corrodes, but you can change its properties. Let's look at some of these alloys. Gold is extremely soft, so what they do is they mix it with a bit of nickel and copper, which makes it tougher and harder, and then it can be used for different things. And I've just said there, things can be used for different things. For example, if we take copper and it's mixed with tin, or copper can be mixed with zinc, this makes bronze, and this makes brass. The alloy of copper and tin is called bronze, and that's used for statues. It's not that reactive, it's tougher, it's more brittle than soft. Copper with zinc, which makes brass. Brass is used for things like ornamental things, doorknobs, door furniture, and things like that. We're using an alloy to change the properties of the base metal, the main metal. Let's take another example. You take something like iron. When iron is mixed with carbon, you get steel, and you get things like high carbon content, and you get low carbon content, and these affect the nature of the metal. High carbon steels, they are extremely, would you believe this, hard. Things like used in steels for chainsaws, milling machines, etc. Whereas low carbon steels, they're not that strong, they're more flexible, so they can be used in the car industry. And then you get things like stainless steel. Stainless steel, they look shiny, and stainless steel is an alloy of iron with some carbon, but then they add nickel or chromium, and that these are less reactive than the iron. So we've looked today, now looking back, I've looked at alloys. Alloys gives metals, changes its properties, which extends its use, its lifetime. It can be used for different products because different products require different properties. In the next video clip, I'll be talking about ceramics, composites and polymers, all these materials which are, I was going to say, are quite new, extend the range and use of a material.